In this video, we're going to talk about simulating probability distribution. Simulations typically use computer in order to visualize or perform tasks to give users outcome based on theories or applied problems. Simulation is the imitation of a situation or a process. A simulated model attempts to copy the behavior of the situation under consideration. In order to understand how simulation works in probability distribution, let's take a look at this example. Let's say we need to get 4 random bags of blood in a blood bank with only 2 types, which is A and B. Let's find out what is the likelihood that the total number of blood type A picked out in the bank will be at least 3 in 100 trials. For this example, we will be using Microsoft Excel to simulate. Let's put the 4 samples in each column, namely bag 1, 2, 3, and 4. Set type A is equals to 1, set type B is equals to 0. In cell A2, we will input equals run between parentheses 0, 1. This will give us a random numbers between 0 and 1. Drag the corner in order to set the other sample with random blood type. Drag it down until 100 tries. As you can see, our data will now be in cell A to A101. Keep in mind that 1 will be type A and 0 means it is a blood type B. Now let's set cell E to be number of blood type A for every trial. To get this, we need to input the formula equals SUMIF parentheses A2 colon D2. Let's drag this down until 101. So in trial 1, we have 3. In trial 2, we also have 3. Now it says here that bag 1 is type A. Now we are going to find out the probability that out of 4 bags, you get exactly 3 blood type A. To get this, we need to set cell G4 and input equals COUNTIF parentheses E2 colon E101 comma number 3. This tells us that if the number is 3, it will be included or counted, and this gives us the result of. For the probability, we will have the value in G4 divided by 100, which is the number of trial or the number of data we have. So we have, if any of these values are changed, the results will also change. Note that the value change because whenever the list refreshes, the random values also change. As you can see now, it is 29. This occurs whenever you undo something or redo. The value randomly applied or designated to the bags changes. The sense of using this is we can simulate the outcome of getting blood without not actually trying to do it in real life for 100 times, so as the other situations. This is just a simple example and demonstration on how we can simulate probability distribution. Now in the screen is an example of computing the binomial distribution with Excel. As you can see, the input is n, which is the number of trials, with a value of 15. The p is the probability of success, which is 0.8. X will be the actual values from 0 to 15. We will be using the formula binom dist in Excel. Binom dist calculate the probability of drawing a certain number of success in a certain number of tries given a population of a certain size, containing a certain number of success with replacement of draws. Now we have the binom dist. Included in the parentheses is the x value, comma, number of trials in cell B1, and probability in D1, comma, then false to indicate that we don't need a cumulative distribution. Now we have the binomial distribution for each trials. We can also graph this distribution by selecting the values on the charts. Click on the bar charts. Here we can change or indicate the source of values of the x-axis or y-axis by highlighting or selecting the datas. As you can see, it displays the binomial distribution when n is equals to 15 and p is equals to 8. This data tells us that we will most likely to have 12 successes. The probability of getting 12 successes is 0.25. Next to 12 is 13, and so on. There are many other simulation programs in which you can perform and acquire data in the fastest way. What I have given you is only the basic example. There is still other type of probability that you can perform on simulations such as Poisson distribution, Monte Carlo, binomial, and other more. You just need to know what are given or what is asked to you so that you can enter the right data. That is all, and thank you.